Okay, imagine this for a second. You're building something really groundbreaking, a new decentralized app, maybe a global insurance platform, something totally peer-to-peer.
Right, that pays out automatically based on real-world events.
Exactly. Or maybe like a real-time gaming marketplace where item values shift constantly. What's the biggest roadblock you might hit?
Hmm. Getting reliable outside data onto the blockchain, I bet.
That's usually it. Getting trustworthy up to the second info,
Yeah.
stock prices, weather, whatever, into that secure, sort of isolated blockchain environment.
Yeah, blockchains are great for security, but they're deliberately walled off. They can't just peek outside.
Precisely. And that fundamental challenge, that's what everyone calls the Oracle problem.
It's a big one.
So today we're doing a deep dive into Band Protocol. It's a system designed specifically to be that bridge.
The crucial link.
Our mission here is to unpack how it grabs that real-world data and pipes it securely and surprisingly fast, actually, over to smart contracts.
And what's really interesting is how Band Protocol uses its core, BandChain, to tackle this. It's built as a chain-agnostic Oracle pipeline.
Chain agnostic, meaning it works with different blockchains.
Yep. It's not just about delivering the data, but ensuring it's accurate, reliable, and accessible pretty much anywhere it's needed. It's serious infrastructure.
So as we get into this, you'll see some really smart ideas, like how the community actually steers which data gets prioritized.
Like a decentralized steering committee.
Kind of.
Right.
And how security works to prevent bad data, plus how data can literally be tunneled to any blockchain.
Those tunnels are pretty clever.
Okay, let's start at the beginning then. This BandChain. What is it, fundamentally?
Well, at its heart, BandChain is a blockchain, but one built specifically for this Oracle job. It uses the Cosmos SDK.
Ah, okay, so it leverages that whole ecosystem.
Exactly. The Cosmos toolkit is great for building these specialized interconnected chains. BandChain's sole purpose is bridging that gap, connecting blockchains to the real-world data they desperately need. Think of it like a high-speed data feed, especially for things like real-time price data.
Which is essential for DeFi.
Absolutely essential. Lending, synthetic assets, decentralized exchanges, they all need fast, reliable prices.
You mentioned real-time and fast. Just how fast are we talking?
You're talking sub-second data latency. That's a core goal.
A sub-second, wow.
Yeah, BandChain's block time is tuned to be under a second, and it has capacity specifically reserved for these Oracle updates.
So validators can push updates almost instantly?
Pretty much. Across hundreds of different price symbols as soon as new information hits. This is crucial for things like decentralized perpetual futures markets.
Right.
A tiny delay there can cost a lot.
Right, timing is everything in those markets. Now, is this just about crypto prices or does it go broader?
Oh, much broader. That's where price signal generalization comes in. They call data points signals, not just tickers.
Signals, okay.
And a signal can represent basically any asset with a price. So, yes, crypto, but also commodities, stocks, maybe even, weather data points if they have a quantifiable value attached.
So it could enable totally different kinds of dApps.
That's the idea. Think insurance based on weather signals or tokenized real estate needing price feeds. Anyone can actually propose new signals and data sources through a registry. If the validators approve, it gets added.
And you mentioned it's chain agnostic. How does it manage to connect to potentially any blockchain? That seems like a big technical lift.
It is, but it's designed for it. It integrates smoothly with existing interoperability protocols like IBC, the Interblockchain Communication Protocol from Cosmos.
Okay, so it can talk to other IBC-enabled chains.
Yes, and the architecture is designed to make adding support for new non-IDC chains relatively straightforward as they come online. It uses underlying providers and also this novel threshold signature approach.
Threshold signature?
Yeah, it's a way for a subset of validators to securely sign off on data for another chain without needing every single validator, which makes it more efficient and cost-effective.
Okay, so BandChain is fast, handles lots of data types, connects broadly. But who decides what data gets prioritized? If it's decentralized, it can't be one company making the call, right?
Exactly. That brings us to the signaling hub. It's a really key part of the design.
The signaling hub, what does it do?
It basically coordinates which price symbols the validators should be actively publishing and updating. It ensures the network focuses on the data that users actually need most.
And the community drives this. How?
Directly. Anyone who delegates Band tokens gets to vote.
So staking Band gives you voting power.
Right, precisely. Your voting power is proportional to your stake. You use a specific transaction, managed bit signals, to vote for the symbols you want prioritized. Your latest vote overrides previous ones.
And the more votes a symbol gets.
The more often validators are required to update its price on BandChain. It directly links community demand to data freshness.
That's a neat feedback loop. So how does that voting power translate into, say, an update every 5 seconds versus every minute? Is there a formula?
There is. It's called the feeding interval, and it's calculated based on the total signaling power behind a symbol. There are parameters like min interval and max interval set by governance.
So boundary conditions.
Right. A symbol needs a minimum amount of voting power, called the power step, just to be considered active. After that, its power determines the interval, calculated basically as max interval divided by a factor derived from its power, but it can't go faster than min interval.
So more popular data gets updated more frequently up to a certain speed limit. Makes sense.
Exactly. It keeps things efficient.
But can the system handle, like, thousands of different data feeds if people vote for them? Or does it get overloaded?
Good question. There's a mechanism to manage that called the current feeds update.
Okay.
Periodically, based on another governance parameter, the system refreshes the list of actively supported symbols. It takes only the top symbols based on voting power up to a maximum count.
Ah, so there's a cap on the number of active feeds at any one time.
Yes, but that cap can be adjusted by the community through governance if the network capacity grows or demand changes. It balances inclusivity with performance.
Right, that makes sense. Okay, we've got data flow, community signals, but the crucial part, data integrity. How do we know the prices aren't just wrong? What stops a validator submitting bad data?
This is fundamental, obviously. It boils down to data security through economic incentives. Validators have to stake SDK Band.
Skin in the game.
Exactly. They put their own capital at risk. Now, proving intent if data is slightly off is hard, but validators risk losing their delegators and therefore revenue if they consistently provide bad or unreliable data.
So the community policing helps keep them honest.
Very much so. And to actually manipulate the final medianized price, you'd need to control over half the total voting power, which gets incredibly expensive.
That's a high bar.
It is. And look, BandChain V2 has been running for years now with reportedly 0 data corruption incidents.
Yeah.
That track record speaks volumes.
That's impressive.
Plus, there's an operational requirement. Validators must broadcast price updates, MSG submit signal prices, for all the active symbols within the required intervals. If they don't, they get deactivated and lose revenue.
So they're incentivized to be both accurate and timely.
Correct.
Now, you mentioned earlier that Band doesn't strictly tell validators how to get the raw data. If it's not prescriptive, how does quality control work? Couldn't they just scrape a dodgy website?
Well, they could, but here's the clever part. Transparency. Validators are required to disclose their data sourcing methods for each signal.
Ah, so they have to publish their strategy.
Yes, and then it's up to the band delegators, the community with the voting power, to decide which validators they trust based on those disclosures. If a validator uses questionable sources, people likely won't delegate to them.
So it becomes a sort of reputational marketplace for data sourcing.
Pretty much. Quality is maintained through informed community choice and oversight, not top-down rules.
Okay, so multiple validators submit prices based on their disclosed methods. How does BandChain merge all these potentially slightly different prices into one single reliable price for a smart contract?
That's the aggregation algorithm. It's not a simple average, because that's too easy to manipulate.
Right.
Instead, it uses the weighted median value of all the prices submitted by active validators. If a validator reports unavailable, they're just excluded from that specific calculation.
Weighted median. So some validators' prices count more than others based on state.
Based on their voting power, yes.
Yeah.
But there's another twist, a recency multiplier.
A recency multiplier. How does that work?
It gives a temporary boost to the influence of more recent price submissions, especially from validators with smaller stakes. For example, those with very little power might get a 6x multiplier temporarily, while the biggest players have a 1x multiplier.
Why do that?
It helps the aggregated price react more quickly to rapid market movements. Newer data gets factored in faster. But because it's still a weighted median, you still need significant economic power to actually shift the final price improperly. It balances responsiveness and security.
That's actually quite sophisticated.
Yeah.
Balancing speed and manipulation resistance.
That's a clever design.
All right, so we've got reliable aggregated data on BandChain. Awesome. But my dApp is running on, say, Ethereum, or maybe Avalanche. How does this super reliable BandChain data get there without a centralized bridge, which would defeat the purpose?
Perfect question. That's exactly the job of data tunnels.
Data tunnels sounds cool. What are they?
They are the mechanism for dApp developers to transmit price data from BandChain to other public blockchains, again, without needing a trusted intermediary. It's the decentralized cross-chain bridge for this specific Oracle data.
And can developers tune these tunnels for their specific needs?
Oh, yes, highly customizable. When a developer creates a tunnel, they specify which signals they need. But also, crucially, the feeding interval. How often BandChain should check if it needs to send data and a price deviation trigger.
Price deviation, meaning?
Meaning the data only gets sent if the price has changed by more than a certain percentage, say 1%, since the last time it was sent.
Ah, so it's not just pushing data constantly. It sends it either on a timer or R if the price moves significantly.
Exactly. BandChain monitors these conditions automatically. A delivery happens if the time interval is up RR, if the price deviation threshold is crossed. Super efficient.
That avoids unnecessary transactions and fees. Speaking of fees, who pays for this? Running these checks and sending data across chains must cost something.
It does. Each time data is successfully delivered via a tunnel, the tunnel creator pays a fee in a band.
Okay.
The fee has two components. A small fixed fee per delivery, regardless of how many signals are in that batch from the same tunnel.
Predictable.
And a variable part that depends on the specific tunnel setup and maybe the destination chain's costs. The key thing is, the tunnel creator needs to keep their tunnel topped up with Banda.
Like a prepaid gas tank for data.
Exactly like that. If the balance runs out, the tunnel automatically deactivates, and no more data flows until it's refilled. It's self-sustaining.
Seems like developers have a lot of control even after setting up a tunnel.
They really do. They're not static. A creator can modify their tunnel, change the signals, the interval, the deviation trigger.
Handy if your app's needs evolve.
For sure. They can easily reactivate a tunnel that ran out of funds just by sending Band to it. They can also voluntarily deactivate it, maybe to save costs if the app is temporarily offline.
Pause the data flow.
Right. And there's even a function to manually trigger a delivery right now, bypassing the normal interval or deviation checks. That could be vital in extreme market volatility or something.
Wow, okay. That's a comprehensive set of tools.
And it's designed to be flexible for builders.
So let's pull this all together. What does Band Protocol mean for you listening out there, whether you're building dApps, using them, or just watching this space evolve? We've seen how BandChain tackles this really tough Oracle problem.
Yeah, getting that reliable real-world data onto the blockchain.
Securing it, making sure it's accurate using those economic incentives and clever aggregation.
And then making it available flexibly through those tunnels to pretty much any blockchain that needs it.
It really feels like a vital piece of the puzzle for the whole decentralized ecosystem.
Absolutely. If you think bigger picture, infrastructure like Band Protocol is what allows decentralized applications to mature beyond simple token swaps. You need this kind of robust, decentralized Oracle for complex finance, for insurance, for gaming, for anything that needs to react to the real world.
Without it, dApps stay kind of isolated.
Exactly. So all these pieces, the community-driven signaling hub, choosing what data matters, the careful aggregation, balancing recency and security, the customizable data tunnels, bridging chains, they all work together.
They enable dApps to actually use that external information reliably.
That's the core function.
So, here's something to think about as we wrap up. Consider the sheer variety of real-world data that systems like Band Protocol could eventually stream onto blockchains. We're not just talking finance.
Right. Think climate data, logistics information, sports results.
What kind of completely new decentralized applications, things we maybe can't even imagine yet, could be unlocked when you have that fast, secure, customizable flow of information bridging the physical and digital worlds?
It really does make you wonder what comes next, doesn't it?
It certainly does. A lot to chew on there.